Hey, good morning, Hisham. Can you just let me know in the chat if you can hear me? Okay, thank you. Okay, we're gonna get started right away. Well, maybe not right away. Right now, it looks like there's 11 people, so I guess we'll just keep waiting. I mean, I don't think that we're actually gonna get 100% attendance, but I'd like to see that maybe get up to hopefully like 20 people. It looks like it's rising now. We've got 14 people. So yeah, I think I said that we'd wait about 5 minutes. So let's give it till 9:05. If you're here, stick around. Don't go away. But yeah, we'll get started any minute now. Okay, guys, I'm gonna make another cup of coffee, and when I get back, we'll get started. looks like we got about 20 people here. We've got lots of stuff going on in the chat. This is great. This is everything I ever could have asked for. You guys are awesome. Yeah, how are you guys doing? Do you have any cool quarantine stories yet, or should we just jump right into math? What do you say? Do you want to have a quick chat first, or where are you guys at? No, okay. So no one's really responding to my question. So I guess we'll just jump right into math. Oh, someone made ice cream. Someone wants to have a chat. Uh-oh, I think Max just sneezed. Good thing he's in quarantine. Oh, 12 hours of homework. That's a lot of homework. Awesome. Yeah, I've mostly just been sticking around here. Played a lot of video games yesterday. Oh, Shani did some science fair. Oh, Karen was the homework. Holy smokes. 10 hours of homework, that's a lot. Holy smokes. So you guys are still doing the science fair. That's still going on, eh? Interesting. Yeah, I didn't really do a whole lot the past couple days. Mostly, like I said, just played some video games. It did take a long time to be able to figure out this this live streaming thing. I spent a lot of time kind of figuring this out. By the way, I have my camera on. I kind of just turned that on so you'd be aware that like I'm actually here. I'll probably turn that off when we're in the middle of the lesson. Yeah. Oh, so there's presentations for science fair. Go to the ODD. Okay, well, I guess we'll get started then. Yeah, let's pause on the chat for a little while. So going forward, let's use the chat for just like questions about either the homework or anything that I'm working on right now. So before we get started, what I'd like us to do is look at a couple questions that a student asked me about. Let's see here. Okay, there they are. A student asked me about a couple of questions, so I thought that we'd go over some of the homework questions. In particular, we're gonna take a look at. Oh, by the way, this is my cat Goose. She wants to be on the internet. What was I talking about? Yeah, so we're going to do questions 5, 12, and 18 together on the homework. So let's take a look. Okay, number 5. Where are you? Here we go. Oops. Number 5, and we're doing the simplifying rational expressions. Okay. Can you guys hear everything okay? Like, does this is this working out okay? Keep in mind, there's like a good 10-second delay, so when I ask a question, I might just have to pause while you guys respond in the chat. Yeah? Okay, perfect. Thank you guys. If there's ever anything that's like going wrong, if I'm writing off screen, you can't read something, just say it in the chat. I'm monitoring the chat pretty closely, so I've got my eye on the chat. So I'm gonna do this, and this. Okay, this is gonna work like this. Okay, so what did I say? Numbers 5, 5, 12, and 18. So let's start off with question 5. So this one is, well, I've got a minus 6 as a numerator, and that's all on top of a squared plus 3a minus 18. Okay, and then I'm multiplying that with 9 minus a squared all over a minus 6. So I've got a lot of factoring to do. But right off the hop, one thing that I can do is, well, maybe I'll leave that for later, but hopefully you can see that I should be able to cancel this with that, right? That should be the, what are we saying in the chat here? Did I hand out the homework? Yeah, so the homework was put on the website. Yeah, so so hold on a sec. Let me just pull up the website here so you can see. Come on. Math Bennett. Yeah, so I'm just gonna do this with the live stream. Hopefully you can see this okay. Yeah, so if you go to the grade 9 section, oh, there's us. The homework is right here, simplifying rational expressions. So I'm posting all the homework on the website. So if you haven't had a chance to do it, that's okay. But it'd be a good idea to work on it now. And kind of my attitude about this is, and I hope you agree, that like hopefully having some schoolwork and some things to do can help you sort of get through this time, right? I know that a lot of people are kind of suffering from boredom, which is pretty normal. But hopefully this gives you something to do, right? Like I don't think this is going to take 10 or 12 hours. This worksheet probably in total would maybe take an hour. But yeah, if you want to watch YouTube 24/7, then you might struggle. But yeah, in any case, let's do that the question I was just talking about. Okay. So we got some factoring to do. We can certainly factor out the a minus 6. We can cancel those common factors. But let's leave that for now because what I want to do is I want to do all the canceling all at once. That way I can see the non-permissible values all at once, or as the worksheet calls them, the excluded values. So let's start off by factoring this one. So we're going to factor that. So I'm looking for two numbers whose product is negative 18 and whose sum is positive 3. That is, well, I'll just write that right here. I've got, well, it's going to be positive 6 and negative 3, right? So I've got a plus 6 and a minus 3. And I still have a minus 6 on the top. And over here, I've got, well, okay, so now let's factor 9 minus a squared. So this is a special type of quadratic. This is called a difference of squares. Difference of squares. I call it the difference of squares because it's a difference, right? Difference means subtract. So we've got a difference, and both of those are squares. So we've got a 9, that's a perfect square, and a squared, that's a perfect square. So a difference of square, the way it works is that 9 minus a squared, that ends up being equal to this. I've got 3 plus a times 3 minus a. And that's what we call a difference of squares. And if you like, you can kind of think of it as like, okay, we're looking for a number who, when I multiply it together, I get 3, and when I add it together, I get 0. That's kind of what's going on behind the scenes. We do know, okay, okay, wait, is the homework watching the videos or a worksheet? Okay, good question. So, the homework is the worksheet. I do still need you to be doing some of the work. Currently, this homework is not worth any marks. Hopefully, at some point, I'm gonna have some kind of digital system for handing in assignments and things like that. In any case, yeah, this homework is not worth marks, but there are videos that will help you with the homework. But it looks like you guys already addressed that in the chat. But just to be clear, yeah, I'm still assigning homework. So yeah, like if you go to the website, there is a button that says homework. Maybe you mistook that for a title, because the video is also called Simplifying Expressions. In any case, yeah, there's a worksheet. You got to do the worksheet. How will we hand in pictures of our notebook? Okay, good question. I don't want to, so I'm just not gonna answer that because I'm kind of in the middle of figuring something out in regards to handing in homework or handing in assignments that are worth marks. But the long and short of it is I'll just be using some kind of software that allows you to, yeah, basically use your smartphone to take a picture of your work and then hand it in to me. But I don't want to go into too many details because things may be subject to change. So anyway, let's get back to this question. So I've factored this difference of squares. So the numerator is going to look like 3 plus a and 3 minus a. And the denominator stays the same, which is just a minus 6. Okay, so let's talk about the non-permissible values. So the non-permissible values are going to be these guys right here. So I know that this cannot be 0, this cannot be 0, and this cannot be 0. So in other words, a cannot be equal to negative 6. A cannot be equal to positive 3, and A cannot be equal to positive 6. The reason for that is if let's say A was equal to negative 6, then that would make this term equal to 0. So if A equals negative 6, then A plus 6 is equal to 0, and then we'd be dividing by 0. So we can't have any of these values. So in set notation, so the NPVs are, so A cannot be in the set where we have negative 6, positive 3, and positive 6 in the set. Okay? So that's our set of non-permissible values. Now let's start factoring some of this stuff out. So this A minus 6 cancels with this A minus 6. And let's take a look at these two guys right here. So A minus 3 and 3 minus A. They look so similar. They've got an A, they've got a 3, and they've got a minus sign between them. So we can actually factor these out. So what I'm gonna do is I'm gonna just rewrite this because it's looking a little bit messy. I'm gonna write just everything else that we have left. So I've got let's see, I've got 3 plus A times 3 minus A, that's my whole numerator, and the denominator is A plus 6 times A minus 3. And I want to focus on this portion right here, okay? So note that A minus 3 is equal to negative 3 minus A. They mean the same thing. So if I were to sort of turn this minus into like a negative 1, which means exactly the same thing, this would be, well, negative 1 times 3 plus negative 1 times negative A, which would give us, well, negative 3 plus A, which is exactly what that is. So what I'm trying to say here is that I can just turn one of these 3 minus a's into an a minus 3. So when I do that, I'll get a minus sign outside of here. So I get 3 plus a times a minus 3. So this is what I've changed. And in the denominator, I get a plus 6 and a minus 3. And now I can cancel these out. So my final answer is negative 3 plus a over a plus 6. And if we just take out all the brackets, what we'll be left with is the following. We've got negative 3 minus a over a plus 6. And I believe that's pretty much what we have in the solutions. Is that right? Let's see. So I'm just going to head over to the solutions. That was number 5. And number 5, yeah, negative 3 minus a over a plus 6. And then the non-permissible values are 3 minus 6 and plus 6. Perfect. The solutions are right on the worksheet. So if we go over to the worksheet, just scroll down. These are the solutions right here. So this is, come on, that's not what I pointed at. These are the ones for number 5 here. So that's what we just solved. Okay, so we did that. Okay, so that was one of the questions that a student asked me. Another one was number 12. Number 12. So number 12 looks like, okay. Number 12. So we've got 4 over 49 n squared plus 14n divided by 2n divided by 14n squared plus 4n. Okay. So I just want to write something on the side here. So just want to make sure that the video is looking okay. Yeah, this looks good. Okay, so one thing to keep in mind about dividing fractions. It may have been a while since you've divided fractions. I believe that's a grade 8 topic. So you probably, the last time you did this may very well have just been like last year. So it may have been a while since you've done any dividing by fractions. But just as a refresher, let's just write a little note about dividing fractions. So it looks something like this. So if I have a over b divided by c over d, that's equal to, well, the first one doesn't change, so this is still equal to a over b, but now I can change this into a multiply, and I get d over c. Okay, so it's important to know exactly what's happening with the fractions when we're dividing them. Basically, the second fraction gets flipped upside down. Now there's all sorts of reasons and different understandings that you can achieve, but for now all we need to know is just that second fraction gets flipped upside down, and that's gonna really come in handy here. So before we do that, though, I want to factor all of this just so we can be absolutely sure about what's going on, because with our non-permissible values, we still have to be sure that we don't have a 0 on any denominator at any point during the question. At any point, if we ever have 0 in the denominator, that is going to give us a non-permissible value. We can never divide by 0. It's never okay to divide by 0. So let's factor the numerator and the denominator. Looks like there's not a whole lot we can do in the numerator, so we'll just leave it as is. The denominator, well, let's focus on that. So we've got 49n squared plus 14n. Looks like the greatest common factor of the coefficients is 7. Is that? Yeah, I think it's 7. And then the greatest common factor of the variables is just n. So we've got 7n. When I factor out a 7n, I'll have another 7n in here, and I'll have a 2 left over. And I'm going to keep this division symbol, so this is still divided by, and I'll have 2n all over, and it looks like this time I can factor out, again, another 7n. So I've got 7n over, multiplied by, 2n. Oh, sorry, I can't do that. I can't factor out a 7n. I can factor out a 2n, pardon me. So I'll factor out a 2n, and what I'm left with is, here's my 7n. This is what I thought that I saw. So I've got a 7n and a plus 2. Okay, there we go. That looks better. Are you allowed to use calculators? Well, yes and no. Depends on what kind of calculator we're talking about. If you have just a basic scientific calculator, and I wish I had some of my calculators here with me. I left them all at school. But if you have just like a regular scientific calculator that looks something like this, so let's just go scientific calculator. Okay, something that looks like this. That's fine. So yeah, if you're going to be using things like this, that's okay. What I don't want to see is a graphing calculator, because that can just do pretty much the whole thing for you. So something like this, like a TI-84, something like this, you can tell this thing's like it's like an iPhone almost in terms of all the functionality. So yeah, no graphing calculator. It looks like you guys have already addressed that in the chat. But yeah, a scientific calculator is fine. Keep in mind though, it's a really good idea to be able to do this stuff in your head. I mean, I'm not asking for like huge numbers here, right? I mean, really all we were looking for were factors of 49 and 14. I'm hoping that like the number 7 just kind of pops out and it's like 7, 7, 7, right? Like between 49 and 14, if I'm looking for factors of 49 and 14, like my brain immediately goes towards 7, because I know that 7 goes into 49, 7 goes into 14. So if you want to fiddle around with a calculator, that's fine, but it's probably going to be way more beneficial for you to be able to do this in your head, because the more time you spend on these problems, the longer it's going to take, right? And then your homework is just going to take that much longer. So if you can do it in your head, then it really speeds things up. Hold on a second. Sorry, my cats are being bad. Okay, let's see here. Where are we? Okay, yeah. So I factored the numerator and the denominator here. There wasn't much to do in the numerators, but let's take a look at what our non-permissible values are. So my NPVs. Okay, so here if n was equal to 0, we'd have a problem. So n cannot be equal to 0. Here, this cannot be equal to 0. So 7n plus 2 cannot be equal to 0. Or in other words, 7n cannot be equal to negative 2. I'm just solving for n here. So in other words, n cannot be equal to negative 2 over 7. Okay. So that's another non-permissible value. And it looks like I've got the same thing over here and over here. So it looks like I only have 2 non-permissible values. I have 0 and negative 2 over 7. Okay. NPV. What is an NPV? That is a non-permissible value. It means, oh, thank you, Hisham. It means that these are values that n is not allowed to be equal to. Like non-permissible, like you do not have permission to equal 0. So in other words, if n were to be equal to 0, remember that n is a variable. So n could pretty much be equal to anything that we want it to be. So if n were equal to 0, then, well, in this case, 7n would be equal to 0, and then we would be dividing by 0. Okay. Okay, Mad Dog. Okay, I'm gonna come back to that. I'm gonna solve this question, and then we'll go back to turning that 3 minus a into an a minus 3. Okay. So we found the non-permissible values. So let's finish this question off. So now I've got well, 4 over 7n times 7n plus 2. And now I'm going to multiply by the reciprocal. So I've got 2n times 7n plus 2 all over 2n. And now I can start canceling some common factors. So this 2n cancels with that 2n. This 7n plus 2 cancels with that 7n plus 2. And then all I'm left with is 4 in the numerator and 7n in the denominator. And that's our final answer. Aha. Okay, so let's quickly go back to this question that Mad Dog was asking. Not sure who that is. That's okay. I've got a minus 3 is equal to negative 3 minus a. Now that's just a fact. Why is this a fact? Well, let's take a look at the algebra. So let's just simplify this. So negative 3 minus a is equal to negative 1 times 3 minus a. That's what this minus sign really means. It means negative 1 times 3 minus a. So this is equal to, well, I've got negative 1 times 3 plus negative 1 times negative a, right? I just used the distributive property. And let's figure out what that is. Well, negative 1 times 3 is negative 3. And negative 1 times negative a is positive a. And look, that's negative 3 plus a, which is the same thing as a minus 3. Okay. How long is the live stream? Because my computer is dying. We are going to 10 o'clock. So, yeah, probably a good idea to pull out a charger. So we're going to be doing just like a regular class. So we're kind of pretending that this is our virtual classroom. So, yeah, go grab a charger because your phone is probably gonna die, or your computer, whatever you're using. Okay, so let's do what was it, question 18 next. Let's see here. I think it was it 18? I think it was 18, yeah. 12 and 18, yeah. So we'll do 18. Great. Okay, so we got 18. 18 looks like this. 7 over m minus 2 times 10 minus 5m all over 5. Okay. Wait, where did we get the negative 1 from? Yeah. Yeah, okay. So okay, I guess we're not quite finished with this. Okay, so this is a fact. So really all we're doing here is we're saying, okay, if I have a minus 3, I can change it to 3 minus a by multiplying it by negative 1. So basically, we can replace a minus 3 with negative 3 minus a at any point. It's kind of like saying, so just like we can replace, I don't know, let's say, 4 over 6 with 2 over 3, right? They mean the same thing. So if it's more convenient to have 2/3 than 4/6, then you can go back and forth. They're equal. They have, they look different, but they're the same thing. So these two things, they look different, but they're actually equal. So in the last question, it was useful to have it in terms of an a minus 3 instead of a 3 minus a. So we changed it from 3 minus a to negative a minus 3. So that works for anything. So in general, then this works for any value. So if we have like x minus y, we can replace that with negative y minus x. Doesn't matter what x or y are, we can always just replace. So basically you can change the order of a difference, but there's a factor of -1 that you have to include. So that's what we did in that last question. I'm glad that you're bringing. Oh, thanks, Madeline. I'm glad that you're bringing it up, because that's kind of the whole point of these live streams, is that you can actually ask these questions. So I'm very pleased that you guys are actually asking questions, and we have some engagement here. This is fantastic. I really couldn't have asked for a better class in this regards. You guys are really awesome. Isn't it negative y plus x? No, because we have this big negative sign sticking out. So yes, this right here is also equal to negative y plus x. But then if I put a negative sign in front of it, then all of a sudden this becomes positive y minus x, right? That's kind of what we're doing here. Okay. Okay, let's go back to question 18. Okay, so 18 looks like this. Okay, so I'm going to factor this a little bit. There's not a whole lot of factoring to do, but it looks like the top right term, this one here, we can factor it a little bit. So I've got 7 over m minus 2 times... Okay, and then this is the one I want to factor. So 10 minus 5m looks like a 5. I can pull out a 5. So take out a 5. I'm left with 2 minus m. Oh, and look at that. We're going to be able to use our fact in this question here, too. Okay, so let's take a look at the non-permissible values. So in this case, m cannot be equal to positive 2, and that's pretty much it. When m is equal to positive 2, we have a problem. So if you want, we can write this in our set notation and say that this is just the set with the number 2 in it. Okay, so wouldn't it be nice if we could cancel out this m minus 2 with this 2 minus m? Well, yes, we can. So let's rewrite this. This is all equal to, well, 7 over m minus 2 times... well, I'm going to change the order and pull out a minus sign. So I'm going to change this to negative 5 instead of positive 5 times m minus 2. And look at that. We just used our trick one more time. Okay, so now I can cancel out some factors. So this m minus 2 cancels with that m minus 2, and this negative 5 cancels with this positive 5 to leave me with, well, don't forget, I didn't cancel out this negative, so this negative is still sticking around. So all I've got is that negative sign and the 7, which gives me a negative 7. Okay? Are there any questions about that last one? Because that last one used pretty much all the tricks that we've been working on. No? Okay. All right. So what we're going to do now is we're going to be doing just a little bit of review. So in the first term, we did stuff that was really similar to this. So that included things like simplifying rational expressions. So in particular, we looked at questions that looked like this. So we're gonna kind of take kind of a small investigation into some of the older topics that we did. So we're gonna be simplifying some more rational expressions. So rational expressions. Okay. And what I'm going to do, so I'm going to do just a few examples here, and then I'm going to post some homework for you guys to do. And I think it's something like 20 to 24 questions. So I'll get you to work on that. And you have to keep in mind, like you guys are you're at home right now, and you don't really have a whole lot of access to a teacher, right? Because normally you guys would be at school, and even if you didn't have class that day, you could drop by my room, that sort of thing. So if you get stuck on one of these questions, this is kind of what I'm getting at. So if you do get stuck, don't fret, don't panic. It's okay. You're allowed to get stuck. But what I'd like you to do is just circle the question that you're having trouble with. And send me like an Instagram message or an email or what have you, and I'll address those questions in our next sort of virtual digital class. So that's what I'd like you to do. Yeah. Okay, so someone missed the last part. I'm not sure what you mean by that. In any case, let's get started with this. Your dog brought in a dead mouse. Oh my gosh. That's gross. Okay, let's do this question here. So let's simplify. Let's do this one here. So I've got 64r over 24r squared. Okay, and not only am I going to simplify this, I'm going to simplify and state the non-permissible values, aka excluded values. Okay. Okay, what if something happens where you can't get all of them? Okay, so if you don't know where to begin, like if you take a look at a worksheet and like if you get completely stuck like on the first question, then send me a message, send me an Instagram message, and I'll probably be able to point you off in the right direction. I'm hoping that these videos help you at least get started. So yeah, let's hope that you can actually do like just one or two questions. What's my Instagram? My Instagram is math.bennett. It's all on the website, so go to mathbennett.com, and right on the homepage there's a link to my Instagram. You can also ask some of your friends. I'm sure they probably have my Instagram as well. So yeah, if you want to just head over to the website, you can do so. And yeah, right at the very bottom, there's the link to my Instagram. Right. Oh, can you even see that? Yeah, right at the bottom. Yeah, you can see that. So that is my Instagram, math.bennett. Okay, let's get back to this. So we're going to be simplifying some rational expressions. So what I want to do is I want to factor 64 and factor 24. So really what I'm looking for is I'm looking for the greatest common factor among these. So I know that 64, if we want, well, let's actually make a quick factor tree. So 64, that's 8 times 8, and 8 is 4 times 2. Okay, so 4 times 2, and then 4 is 2 times 2, and again 4 is 2 times 2. Oops, 2 times 2. So I've got 1, 2, 3, 4, 5, 6. So 24 is 2 to the power of 6. 64 is 2 to the power of 6. And 24, that is equal to 6 times 4. 6 is 2 times 3. These are prime. And 4 is 2 times 2. Okay, so 24 is 2 to the power of 3 all times 3. Okay. Yes, the videos will be saved. I'm going to post this video to YouTube as soon as it is finished being live. So yeah, you can absolutely rewatch these as many times as you want. That was the reason why I decided to go with YouTube. I know a lot of teachers are using Zoom right now, and Zoom is great. But as far as I understand, if you want to save a Zoom video, you have to pay them money, and I didn't want to have to come up with a way to pay Zoom. So we're just using YouTube, so that way it can be live. So it's broadcasted live, but then when we're finished, it'll be saved to my YouTube channel. Okay. So I've got 24, which is 6 times 4, and I've written that out. So now what I want to do is I want to find the GCF. So the greatest common factor is going to be, well, in this case, is going to be 2 to the 3, which is equal to 8. So I'm going to factor out an 8 from the numerator and the denominator. So I'm going to get, well, 64 divided by 8 is 8. So I've got 8 times 8r, and I've got, well, 24, when I take out an 8, I get 8 times 3. I've got r squared. So now you can see that these will cancel out. And I'm left with, and this r will cancel with one of these r's. So I'm left with 8 over 3r. Okay? The non-permissible values in this case, r cannot be equal to 0. Because if we look at the denominator of the original question, r being equal to 0, that's the only way that the denominator can be equal to 0. Okay, any questions about this style of question? This is something that I would consider this to be more straightforward than these factoring questions that we were doing earlier. I think that these have fewer sort of concepts that we really have to wrap our heads around. You're just sort of canceling numerators and denominators. There's not a whole lot going on here. So let's ramp up the difficulty level just a little bit. Let's try something like this. So I'm going to simplify and state all non-permissible values. Let's see here. Let's do this one right here. Okay, so let's try 45 x squared minus 63x all over Is it the same concept as the homework questions, just simpler? Yes. You can use all the same strategies. The questions just look a little bit different. You can still factor. You're still canceling the numerator and the denominator. If you have any common factors, you just cancel those common factors. That it won't all be like factor then cancel common factors. You might have to do some sort of other stuff as well. So let's try this example and see what happens. So this one here, I'm going to factor the numerator. So taking a look at the numerator, I'm looking at 45 and 63. Those ones come up in my 9 times tables a lot, 40, 45, and 63. So I'm going to use, I'm going to factor out a 9. I'm also going to factor out an x because this has an x and this has an x. So let's factor out a 9x and see what's left over. So if I factor out a 9x from 45x squared, I'm going to be left with 5x. And if I factor a 9x out of a negative 63x, that's going to be negative 7 because 9 times 7 is 63. And then on the denominator, I still have 9x squared. So that's convenient because this 9 cancels with that 9, and this x cancels with one of these x's. So what I'm left with is 5x minus 7 all over x. And that's not too bad. Oh, and then non-permissible values. Non-permissible values, well, it looks like in the denominator we can only have one way of making this equal to 0, and that's if x is equal to 0. So x cannot be equal to 0, or if you prefer the set notation, you can just write this. Okay, I think I'm gonna do just one more question, and then I will leave you guys to it. So our next stream is going to be on Wednesday. So no stream tomorrow, but a stream on Wednesday. So hopefully we can get even more people showing up. It looks like we had about half of the grade 9 students in this stream. But yeah, hopefully next time we can maybe try to aim for like 3/4. I kind of assumed that in the very first stream we would have a little bit of difficulty figuring it out, but hopefully we'll have a few more. Should we have our homework done for Wednesday? That would be great. So, I mean, it's kind of hard for me to say yes or no because, you know, we're in quarantine right now, and if you have other stuff that you have to be doing, like if you have someone you need to be taking care of, then of course I'd understand that. But I think for the most part, a lot of us are, you know, have got a lot of time on our hands. So it'd be great if you could do some of this homework. Oh, which one? I have a new worksheet that I'm about to post. So I'll be posting it very shortly by the end of class. So so that means that there will be 2 homework sets. So the one from last week and then one from this week. Okay, so do we need a non-permissible value? Yes, you do need to write all the NPVs for each of your questions. You always have to do that going forward. So anytime you have sort of a sketchy value for x, tell me, because that's really important. Can we factor the x from the 5 and x from the bottom? Oh, good question. Okay. So is this okay? So who asked this? So Nate asked a really good question here. Let's take a look at this. So can we factor these x's? The short answer is no, and the long answer is kind of. So let's take a look at this. So I've got 5x minus 7 all over x. This is a very how do you guys know my cat's name? Goose. I think I already told you that. Goose is my cat, and she's also my avatar in my little icon here. That's a little picture of her. She's currently lying in the sun. I wish I could point my camera towards her. She's super cute right now. Anyway, so can we cancel these guys? Absolutely not. You cannot cancel those. Why? Well, because x is not a factor of the numerator, right? If it looks something like this, x times 5 minus 7, something like this, then yeah, x would be a factor of the numerator, but it is not. Right now, x is just a factor of one of the terms of the numerator. So keep in mind that this is actually equal to this. So 5x minus 7 over x is actually equal to 5x over x minus 7 over x. Okay, so that's using just a straightforward principle of fractions, right? Like if I have 5 over 9 plus 2 over 9, that's equal to 7 over 9, right? That's basically what this is saying, right? So we can split up that numerator into 2 different fractions. In this case, yes, you can cancel out these x because this x is a factor of the numerator. So we would be left with 5 minus 7 over x. So in a sense, you sort of can cancel these common factors, but you have to split it up first. Okay, so can we factor the x from the 5? Okay, so that was that question. So does this mean all the homework, like watching previous videos and doing old worksheets? So, okay, so let's just be clear about what the homework is. So I'm going to be posting homework about as regularly as I would give you homework in class. Videos are kind of like going to class. So, you know, like I said, we all have very unique situations right now. So if for some reason you cannot watch the live stream, that's okay. But it's on YouTube, so you can watch it. It's kind of like in school. Like some days you're going to be sick. That's okay. You're allowed to be sick. But at the same time, it is your responsibility to, you know, get the notes from someone, ask your teacher what you did. In this case, if you missed the stream, just be aware that everything is posted on YouTube. So watching the YouTube videos is kind of just like showing up to class. So is the homework watching the YouTube videos? No. But the YouTube videos are really going to help you do your homework. So so that's how that's going to work. Okay, so I'm just going through the chat one question at a time. So can we just state the non-permissible values, or do we have to write them in set notation? You can write it in either way. You can either write this, or you could write this. Well, actually, if you did write this, write NPVs. I know that some teachers are really picky about your notation. As far as I'm concerned, as long as you tell me what values x cannot be equal to, I'm fine. I'm totally okay if you want to write, x is not equal to 0, or you can write it in set notation. Just be very clear that you're talking about the non-permissible values, and also be aware that you can write it in two different ways, because you know, like maybe next year you'll have a math teacher who really wants you to write it like this, or like this, and maybe next year you have a teacher who really wants you to write it like this. So just being able to go back and forth between both types of notations is really important. Okay, so can we just state the non-permissible values? Yeah, okay. Do we have to watch the old videos and do old worksheets, or does this kind of bring us up to date? Well, I'll tell you what. If you can do this worksheet that I'm going to post in about 2 minutes from now, then we'll call it even, and you should be able to do it. But if you get stuck, watch some of the old videos. I've posted quite a few videos for the grade 9 page. So watch the old videos, and you should be able to do these. So yes, you can write it either way, either all over x or the 5 minus 7. Yeah, for the final answer. Yes, Nate, you can. Okay, so I'm gonna end it there. I'm gonna post a new worksheet on the website. It'll be on there in about 2 minutes. So yeah, I hope that this went okay. Looks like we still have 20 people watching, so that's fantastic. If you have a friend who wasn't able to make it today, just tell them about the fact that this is going to be available on the website, so they should be able to watch it any minute now. And see if you can convince them to show up next time, because that'd be great if we had a larger majority of the class. So I'm gonna sign out, get things ready for my next class, and I will see you on Wednesday. Wednesday is our next live stream. So again, I hope everything is going okay. This is a very strange time for everybody in the world. So if you're feeling a little bit strange, just know that you're not alone. The world is changing all around us. So yeah, if you're thinking that things are a little bit weird, it's because they are a little bit weird. Okay, I will see you on Wednesday, or I guess you'll see me on Wednesday. I miss seeing all your faces, but anyway, hopefully I'll be able to see them sometime soon. Okay, how do I... Okay, end stream. Okay, bye-bye, guys. Oh, hold on. I'm gonna show you a goose. These are my cats. Say bye to my cats. This is Kima right over here, and this is Goose. They're really, really amazing little creatures. Okay, bye guys.